What is 7 hundredths times 10? Well, let's focus first on this times 10 part of our expression, because multiplying by 10 has some patterns in math that we can use to help us solve. One pattern we can think of when we multiply by 10 is if we take a whole number and multiply it by 10, we'll simply add a 0 to the end of our whole number. So for example, if we have a whole number like 9 and we multiply by 10, our solution will be a 9 with 1 0 at the end, or 90, because 9 times 10 is the same as 9 tens, and 9 tens is 90. So let's use that pattern first to try to solve. Here we have 7 hundredths, so 7 times we have 100, or 700. And we're multiplying again times 10. Use this pattern over here, our solution will add a 0 at the end. So if we had 710 times, we would have 700 with a 0 on the end, or 7,000. So 7 hundredths times 10 is equal to 7,000. But there's another pattern we could use here, another pattern to think about when we multiply by 10, and that is that when we multiply by 10, we move every digit one place value left, or one place value greater. So let's look at that one on a place value chart. Here we have a place value chart. To use that earlier example when we had 9 ones and we multiplied it by 10, our 9 moved one place value to the left. It moved up to the tens. Now we had 9 tens. And we filled in a 0 here because there were no ones left. There were 0 ones left. And so we saw that 9 times 10 was equal to 90. So again, it's the same as adding a 0 at the end, but we're looking at it another way. We're looking at it in terms of place value, and multiplying by 10 moved every digit one place value to the left. So if we do that with this same question, 7 hundredths, if we move hundreds one place value to the left, we'll end up with thousands. So 700 times 10 is 7 thousands. Or as we saw earlier, 7,000. So either one of these is a correct answer. 700 times 10 is 7,000. And here's an example with division. Now we have dividing by 10. And as you might predict, dividing by 10 is the opposite of multiplying by 10. So our patterns are also the opposite. Instead of adding a 0 to the end of a whole number, we would drop a 0 at the end. We would drop a 0 at the end. So for an example, if we had 40 divided by 10, we would drop that 0 and end up with 4. If you divide 40 into groups of 10, you have 4 groups. Let's use that over here. 212 tens, so we have 212 tens. So 212 10 times. That's how we got the 0 there. And we divide that by 10. We can use this first pattern we thought of and just drop the 0 on the end. Let's drop that 0, and our answer will be 212. But we could use the place value pattern. We could think in terms of place value, and instead of moving one place value to the left, one place value larger, we're going to move one place value smaller, or to the right. One place value to the right. So what's one place value smaller than 212 tens? If we have 212 tens divided by 10, we want to move this tens one place value to the right, or smaller, which is ones. So our solution would be 212 ones, which is equal to what we already saw, simply 212. So 212 tens divided by 10. We could write the number out and drop a 0, or we could think about place value and move one place value to the right. Either way, our answer is 212 ones.